This is the second lecture on Pleistocene glaciation. Instead of focusing on landforms that were created by ice sheets, now we're going to talk about landforms that were created by alpine glaciers that grew in advance during the Pleistocene. And so here we've got a mountainous landscape before the onset of a glaciation. And what the glaciers did is they totally transformed rivers in their drainage basins by filling these river valleys with glacial ice. So here we've got a full-on glacial cycle, glacial advancement, and we're going to totally transform those river valleys in their drainage basin by glacial erosion. Now we're in the Holocene interglacial, and the ice has melted back, but there are telltale landforms, right, key indicators that there was once a major glacial advancement in this mountainous region. So let's go over the many erosional landforms that you will find in high mountain regions. Now, a lot of these terms are French terms coined by French glaciologists, studying these features in the Alps of Europe. And so the first landform is called a cirque, and it's a bowl-shaped depression at the head of a river valley where the ice started to accumulate. And so here, is the head wall or the beginning of a tributary in a high mountain area, and the glacier, started to accumulate and erode out that river valley. And what you wind up is, with high mountain, scooped out cirques. And they take on, various, kind of forms, but they're very common features in the Rockies of the western United States and many other mountain ranges. Here's an example of the Wasatch Mountains in Utah, and here there are 3 scooped out cirques here. Now the Scottish Highlands, were glaciated, and so the cirques, due to different geology, take on different appearances. But here's another beautiful example of the 3 cirques here. And so another French term is a tarn. All right, and it's just nothing more than a high mountain lake, and it's just the water that is accumulated in that cirque depression. Another French term is a rete. A rete is knife, means knife in French, and it's a narrow, sharp divide by glacial erosion on both sides of a mountain. So here we've got an illustration of, an unglaciated area, and remember what a divide is, right? And so before glaciation, the divides, were round crested. But because we have, glacial erosion on both sides of the divide, we wind up with erosion, and we transform what was once a round crested divide into a knife-like, right, narrow divide. And these are called arêtes. So we've got arêtes everywhere, all right, and they're knife-like ridges. And that creates the classic, alpine landscape. And I've just got one beautiful picture in the Grand Tetons of Wyoming, and there are just cirques everywhere. Actually, the main divide here is definitely an arête. So there were all glaciers eroding on the back side and on the front side. So this is all, you couldn't walk on this. It's so narrow and knife-like. But then there were some glaciers, carving river valleys here. And what was once, round-crested divides are now sharp-crested arêtes. All right, so they're knife-like ridges or knife-like divides transformed by glacial erosion. A horn is an isolated mountain peak from glacial erosion on all sides, right? And so all you wind up with is kind of a pointed feature. And so there, many of the individual mountain peaks of the Alps of Europe are horns. And the most famous, mountain peak is in Switzerland, and the horn, and it's called the Matterhorn. And there's, it's near Zermatt, in Switzerland. And so this is just one of many horns in the Alps of Europe, and that's the most famous one. U-shaped valley. Right, there's another classic alpine glacial landscape feature. So what we have is a pre-glacial river drainage basin. And, rivers in their drainage basins, normally before they really, age and create a floodplain, have V-shaped river valleys. And so once you fill up those river valleys with glacial ice, these valleys are going to be transformed and eroded into the shape of the glacial ice. And so now what you wind up with is what was once the main valley is a large U-shaped valley, all right, carved out by the glacial ice. And then the tributary valleys are also U-shaped, but they're, smaller tributary glaciers filled with ice, and so they're smaller U-shaped valleys, all right. And these tributary glacial valleys, this glacial ice, all contributed to the main valley. So that's why the main valley is, so much bigger. Now that the ice is gone in this image, what winds up happening is these valleys are now reoccupied by rivers, and the rivers are said to be misfit. Of course, it's misfit because this river did not create this valley. This valley was created by a glacier. And so we're going to have rivers, filling in, the tributaries, but they're all misfit. And here's an example of some U-shaped valleys. Here's in the northern Rockies, near Red Lodge in Montana. And here's a misfit river here, right? And so the river certainly did not create this U-shaped valley. And here in Switzerland, we have U-shaped valleys. They're often called U-shaped troughs, but it all depends on the geology. But this is kind of what they look like throughout the Alps of Europe, and here in Switzerland it's famous. Yeah, associated with U-shaped valleys are hanging valleys, and as I mentioned, the glaciers that filled in the smaller tributaries, it didn't erode as deep as the main valley because the tributaries were contributing more ice, and so you wound up now, with misfit rivers reoccupying the valleys, and they're left hanging, because they didn't erode as deep as the main valley that had more ice. And so you wind up with hanging valleys everywhere. And in Switzerland, here's another trough, and they're just waterfalls hanging. All right, here's another waterfall here, just hanging, from the edges of that U-shaped trough. And so it's very common. So the rivers reoccupy. And so you got the site of waterfalls today. And, in Yosemite National Park and the Sierra Nevadas, they were definitely glaciated during the Pleistocene. And this is Yosemite Valley, all right, and it's a U-shaped valley. And today the Merced River is flowing in this valley. It's a misfit river, flowing in a U-shaped valley. And the famous landmark of Yosemite is Half Dome. And before glaciation, this was a full domal mountain, and the giant glacier that carved this U-shaped valley cut this dome in half. So that's our iconic feature of Yosemite, but also our hanging valleys. And so there were many, tributary glaciers that didn't cut as deep as the main glacier valley. So if you ever go to Yosemite, you'll see numerous, hanging valley waterfalls. All right, so let's talk about some of the depositional landforms of alpine glaciers. So as you saw, there was tremendous erosion of the pre-existing drainage basin, and a lot of that eroded material is deposited as moraines. And so I'm just going to introduce you to two more types of moraines. And here's an active glacier here, and another type is called lateral moraine, and that's just all the eroded debris carried along the sides of a glacier. And here's an active glacier here with all the lateral moraine. And then another type of moraine is called medial moraine, and it's a dark band of debris down the middle of a glacier, particularly an active glacier where it's most visible, where two inside lateral moraines meet. And so what you need are two tributary glaciers meeting the main larger glacier. And what you need is the inside lateral moraines joining, and they'll wind up joining and creating a dark band of debris down the middle. And so here's a medial moraine here where two tributaries glaciers had met at one point. And here's some lateral moraine in the Alps of Europe, and this is what moraine looks like. It's just boulders and cobbles and sand and all the way down to clay, and trees too get incorporated. And so that's a nice example of what moraine looks like. And here's an aerial view of an alpine glacier in Alaska, and this one actually has two medial moraines, so there are several tributary glaciers have joined. And there's also some nice example of lateral moraine right in through here, lateral moraine there. All right, end lecture.